It's definitely out of my area of expertise, if you can even say I have an area of expertise, but there are concerns with chemotherapy that it can lead to drug-resistant pathogens, similar to how antibiotics can lead to drug-resistant pathogens. So for this week, we have just a small segment of the data set that researchers used. They had mice, and they put them in different boxes, and they gave them different levels of chemotherapy. One a low dose, one a medium, one a high dose, basically. And then they tracked several different variables. They measured how many different pathogens were each of the mice. But just to keep things simple, actually, I'm going to move this down. These are the red blood cell counts of the mice, just to see, if different levels of chemotherapy led to different levels of red blood cells. This data set here does not directly connect with what they're doing, but this is actual numbers from mice that they pulled. So the box 3, I believe, is, well, actually, I'm not sure off the top of my head. One of these boxes is high dose chemotherapy, one of these has medium, one of these has low dose chemotherapy. So maybe box 3 is high dose because it does look lower. Okay, either way, to complete the assignment, we got to conduct ANOVA, and unfortunately, right now, Google is still updating Google Sheets, and they're doing new privacy things. And there's a package we were going to download called Excel Miner, but that's currently unavailable. So in order to conduct ANOVA, we can use an online calculator. All I did was I Google searched ANOVA calculator. There's tons of different stats calculators online that just work right in your web browser. So I click that link. This is what the ANOVA calculator looks like. And then to get your results, you just need to copy the data. So highlight one column at a time, copy it, and then paste it in treatment 1. Do the same thing for treatment 2, and then do the same thing for treatment 3. And then I'm going to hold off on hitting submit here. But you'll see the p-value. The significance level, you actually you don't need to set it right now. You can just leave it at 0.05. Click calculate, and you'll see the p-value, I believe, in blue. Okay, and you'll need that to make your decision. So using what we learned this week, what is the null and alternative hypothesis for this ANOVA analysis? Remember, in general, an ANOVA analysis says that for the null hypothesis, it says that there is no difference in the mean of the 3 groups. And the alternative should be that there is at least one mean that is significantly different than the other means. So so you're just going to need to write that up in terms of the red blood cell counts in mice. Talk about the mean red blood cell counts in mice when you say your null and alternative hypothesis. And then the p-value you get from that calculator, and then you can do the normal interpretation of a p-value. Remember, if the p-value is low, you reject HO and in favor of H1 or your alternative hypothesis. Okay, but let me know if you have questions. The steps are pretty quick this week because it's a short week.